Hello everyone, my name is Som Gupta. I am an undergrad student pursuing electrical engineering from Institute of Engineering and Technology. So I am going to perform preliminary task for RFID simulation programming for Gazebo harmonics. So for this project idea, we have assigned two tasks. First one is this, and second one is so in task. There's a task describe the step needed to have a gazebo harmonics running on your PC. So for this, we have opened here documentation side of gazebo harmonics. Sorry, it's gazebo harmonic documentation site, and so yeah, it's documentation site for gazebo harmonics. So the for you can see here Gazebo Harmony supports two versions of Ubuntu. First one is 22.04 and second one is 24.04. So you can only run on this Gazebo Harmonics on this Ubuntu's versions. Uh, so for the installation of Gazebo Harmonics, we need to run these two CLI command. After successful running this both of these CLI command, Gazebo Harmonics will successfully install in your PC. So after the installation of Gazebo Harmonics, we need to install ROS Gazebo package for the integration of ROS and Gazebo. So let's open the site for installation of Gazebo with ROS. As you can see here, Gazebo Harmonics supports three versions of ROS: ROS to Rolling, ROS to Jazzy, and ROS to Humble. But default version of ROS is ROS to Jazzy, which needed to be installed Gazebo Harmonics in default. So if you are running Gazebo Harmonics in default pairing, so you need to run this CLI command. But if you not running default Gazebo ROS pairing, so then we need to run this command. So that's all. After the installation of ROS Gazebo package, Gazebo will successfully integrated with ROS. So next, set up a demo project with a robot of your choice. Provide a running example. For this task, I have used my college project, which is AI based robot, which have all the functionality of AMR robot, such as localization, mapping, and navigation. Uh, so you can see here, this is 3D model of my robot, which I'm going to use, and this is simulation of my robot. As you can see here, I have used Gazebo Classic for simulation of robot, but for this task, I have to use Gazebo Harmonics. So I made appropriate changes according to this in my robot package. I've also made a robot server which can launch different launch files of files of my robot, and also control teleop my robot, and also send 2D post estimation to the AMCL package, and also send 2D goal post to navigation nav2 package. So you can see here, this is my robot server which I've made, and I'm going to launch it. So all the are the description of API which is being used to control the robot. I have also made a website which gives web GUI to my APIs to control your bots. So this is a website, robot control dashboard. So I'm going to launch robot and simulation of robot. So simulation of robot is being loaded in Gazebo, and it's here. So this is joystick to tell you the robot. You can see here I can even control the robot using this joystick. Let's launch RVision. So you can see here it is successfully visualizing robot and RVision. Let's select base footprint as fixed frame and launch SLAM mapping. It uses online asynchronous mapping algorithm for mapping. So let's create a map of the moment. So you can see here map of the our environment is successfully being created. So let's launch navigation package. You can also see the status of the different component of our robot. So our simulation and navigation and mapping are currently running, and localization is stopped. This localization is a AMCL package which is not being used right now, and you can see also lifestyle status of all these nodes. So as you can see here, as localization package is not run right now, the status of localization nodes are unknown, and navigation nodes are running right now, so it's showing active. So let's open global cost map. What's the problem with this? Acha, I've selected wrong frame. So let's change it to the map frame, and yeah, this is our global cost map. So let's send to the goalpost for the robot, and you can see here it started. So as you can see here, our robot is successfully achieved goal point, and we can also send goal point using this website. So you can see here, robot start moving. So it successfully arrived at goal point, and there is also one feature. So the map we have created here, we can also save it. All map, save map. So you can see here status map saved successfully. So let's see it is saved or not. So it is here right now. We can open it. So Gsoc in map. So this is map which is created and saved here. This is all functionality of our robot, and that's all from my side for task 1. Thank you.